morning, one and all. Myself, Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So, in the today's lecture, we are going to learn about uniform plane waves or electromagnetic waves propagation in good conducting medium. We are going to learn, right? So, in the previous lecture, what we have learned is how the electromagnetic wave or uniform plane wave is propagating in dielectric medium we have discussed. So, in the dielectric medium case, we have discussed three different cases. One is lossless dielectric medium, and the second case we have discussed is lossy dielectric medium, and the third case is practical dielectric medium, right? So, in a lossless or perfect dielectric medium case, we have assumed sigma equal to 0, and in the lossy dielectric medium, sigma is not equal to 0. Similarly, in the practical dielectric medium case, also sigma is not equal to 0. We have assumed. Then, based upon that, we have analyzed four characteristics of uniform plane wave, that is conductivity, then permittivity, permeability. Along with that, three constants we have discussed as attenuation constant alpha, phase constant beta, and propagation constant gamma. Along with these three constants, we also analyzed intrinsic impedance, that is eta, and it is given by, it is the ratio of electric field strength E to the magnetic field strength H. Right? So, in the similarly, here also the third or one of the wave propagation medium is to be analyzed is here conducting medium. Right? So, before going to analyze how the electromagnetic wave is to be propagating in a good conducting medium, firstly, let me introduce how the what are the medium characteristics are to be defined, how these characteristics are to be defined in different cases of the medium we will see. Then we'll move on to the electromagnetic wave propagation in good conducting medium, right? So for the first, for free space medium, the characteristics are to be assumed as sigma equal to 0 and epsilon equal to epsilon naught, and mu is nothing but mu naught. And for a lossless dielectrics, sigma equal to 0 and epsilon equal to epsilon naught into epsilon r, where mu equal to mu naught into mu r, or the condition it has to satisfy is sigma is far lesser than that of the omega epsilon. And for lossy dielectric medium, that sigma is not equal to 0 and epsilon is given by epsilon naught into epsilon r, and mu is nothing but mu naught into mu r. Okay. Now coming to the important one in this lecture is about good conductors, right? So for the good conductors, the condition, the initial condition which we are going to consider is sigma is approximately equal to infinite, right? And epsilon is nothing but epsilon naught into epsilon r, and mu is nothing but mu naught into mu r. And the condition is to be considered for the good conducting medium is loss tangent, nothing but sigma by omega epsilon is far greater than that of 1, or sigma is far greater than that of the omega epsilon, right? So based upon this means whether the given medium is a type of which medium is given, means depending upon this loss tangent or this is the condition is to be separated whether the given medium is a dielectric medium or conducting medium, right? So if sigma is far greater than that of omega epsilon case, medium behaves as good conducting medium, and if sigma is far lesser than that of omega epsilon case, then medium behaves as good dielectric medium, right? So means at very low conductivity case, at very low conductivities, at very high frequencies case, medium behaves as good conducting medium. At high conductivity and at low frequencies case, medium behaves as good conducting medium, and at very low conductivity case and at very high frequencies case, medium behaves as good dielectric medium. Right? So, in order to identify the given medium is a type of whether it is dielectric medium or conducting medium, we will consider means that loss tangent is far greater than that of one case, medium behaves as good conducting medium, and that loss tangent is less than that of one case, medium behaves as good dielectric medium. Right? So, in order to analyze the uniform plane wave or electromagnetic wave propagation in good conducting medium, we need to consider these are the fundamental assumptions. Means conductivity of that medium is approximately equal to infinite, and epsilon mu can be considered as respectively as epsilon naught into epsilon r, and mu is mu naught into mu r. And the condition it must be satisfied is sigma by omega epsilon, nothing but loss tangent is far greater than that of 1. Okay? And along with that, we need to know all the three characteristics or parameters of the electromagnetic wave as attenuation constant alpha and the phase constant as beta. As our attenuation constant is measured in Nepper per meter, and this phase constant beta to be measured in radians per meter, and propagation constant gamma is nothing but alpha plus j beta, which is equal to j omega mu into sigma plus j omega epsilon under root. And the units for this propagation constant gamma can be measured per unit length or 1 by meter, or it in general meter inverse. And along with this propagation constant, we are also considered the intrinsic impedance eta, and it is the ratio of electric field strength E to the magnetic field strength H, and it is given by j omega mu by sigma plus j omega epsilon root over. Right? So, in order to analyze the propagation characteristics of the different medium, we need to know what is alpha, beta, gamma, and intrinsic impedance eta. Okay, then, so coming to the today's lecture, uniform plane waves in good conductors, good conducting medium, right? So, in order to know the propagation characteristics of this good conducting medium, firstly, we are going to define loss angle and loss tangent. How we are going to define this loss tangent and loss angle means depending upon the conduction current density Jc and the displacement current density Jd. As we know that this conduction current density Jc is given by sigma into E, where sigma be the conductivity of the medium and E be the applied electric field strength. And Jd is nothing but dou d bar by dou t, right? Where d bar is nothing but electric flux density, and it is given by epsilon into E bar, right? So for a time varying fields, this partial derivative term is changing with time, means dou by dou t is replaced by j omega into d bar or j omega epsilon into E bar. If you substitute d bar by this equation, d equal to epsilon into E, then this becomes jd is nothing but j omega epsilon into E bar. Okay, so jd. Then it is the ratio of jc to jd is given by sigma into E bar by j omega epsilon into E bar. This E bar gets cancelled. Sigma by j omega epsilon is to be obtained, right? So where this j by jd is the ratio is given by loss tangent, nothing but sigma by omega epsilon, tan theta equal to sigma by omega epsilon, that is called as loss tangent of the dielectric. Similarly, for loss angle, theta is given by tan inverse of sigma by omega epsilon, right? So as we know that the two conditions for the dielectric and conducting medium is if sigma is far lesser than that of omega epsilon, the loss tangent is small and the medium is said to be good dielectric medium. or sigma by omega epsilon is far lesser than that of one case, medium is said to be good dielectric medium. And if sigma is far greater than that of omega epsilon, then loss tangent is high and the medium is said to be good conducting. Or sigma by omega epsilon is far greater than that of 1, then medium is said to be good conducting medium. Right? So depending upon these two, we will analyze, already we have analyzed good dielectrics, lossy dielectrics and lossless practical dielectrics. Now we'll learn about the uniform plane waves propagation in good conducting medium. Okay, so as a perfect or good conductor means for a perfect conductor is also said to be good conductor. So as a perfect or a good conductor, the condition is sigma is far greater than that of omega epsilon, and the characteristics are to be considered as sigma is approximately equal to infinite and epsilon equal to epsilon naught, then mu equal to mu naught into mu r. Okay. Then, in order to analyze the wave propagation characteristics in good conducting medium, firstly we have considered this gamma, nothing but propagation constant, and it is constitute the two relations as alpha and beta. So gamma equal to alpha plus j beta, which is equal to root over j omega mu into sigma plus j omega epsilon, where sigma be the conductivity of that medium, mu permeability of that medium, and epsilon permittivity of that medium. Omega is the angular frequency of that. Then gamma equal to, so here if you substitute in place of this gamma by nothing but sigma by infinite, right? So here if you take means gamma equal to, what is that equation we have? J omega mu into sigma plus j omega epsilon root over. In this, if you take j omega mu into sigma as common, then this becomes 1 plus j omega epsilon by sigma, then root over. Now for the characteristics of this good conducting medium, initially we have assumed sigma is approximately equal to infinite. Then j omega mu into sigma, then 1 plus j omega epsilon by, if you substitute sigma by infinite, right? So something by infinite becomes 0, then this becomes j omega mu into sigma, then 1 plus 0 root over. Nothing but j omega mu into sigma is obtained as gamma. Nothing but propagation constant of good conducting medium, right? So gamma is nothing but root over omega mu into sigma into j. So we will separate real and imaginary, hence this becomes root over omega mu sigma is to be considered as a constant, and root j is nothing but it is a complex variable. Therefrom we are going to define imaginary, hence we can separate root j as separately, right? So root over omega mu sigma into root j, from this equation we have got. Then, so root of this j function can be written as, right? So root of means, suppose if my complex variable z can be defined as x plus jy, right? So if you are assuming there is no real term, means a real term is 0, then imaginary root j is obtained, means y value is to be considered as 1, then 0 plus j is like this. Now if you want to find the magnitude modulus of j, then if you want to find the phase angle z can be written as, means theta can be written as here tan inverse of imaginary, that is j, nothing but y value is 1, and the real term is to be considered as 0. So tan inverse of something by 0 is nothing but tan inverse of infinite we are supposed to get. Then tan inverse of infinity means that theta value is to be considered as pi by 2 or nothing but 90 degrees, right? So that can be written as, but j can be written as 1 at an angle of 90. But here we'll have root j. So root of theta formula is given by root theta. How we are going to evaluate this root theta means the formula is given by theta by 2. Suppose if you have the theta value as 90, means root 90 can be obtained as 90 by 2, then it is equal to 45 degrees, right? So this is the formula for that. Now to evaluate root over theta function. So 1 at an angle of 90 is to be obtained as the value of j. But here we have got root j. So now to simplify that one, we will write here root over omega mu into sigma, then 1 at an angle of 90. Root 1 value is to be 1 and root theta is to be evaluated as according to the formula, that is theta by 2, then it is to be obtained as 45 degrees. Right? So root over omega mu sigma at an angle of 45 is to be obtained. So this can be written as at an angle of 45 means this can be written as e power j 45, right? So this e power j 45 can be written as the complex function as cos 45 plus j sin 45. Okay. Suppose if we have exponential function means at an angle of minus 45, we will consider for that is e power minus j 45, then it should be written as cos 45 minus j sin 45. But here we'll have a positive function means then this Euler's function can be written as cos 45 plus j sin 45, right? As we know that cos 45 value is root 2, 1 by root 2 plus j sin 45 is also 1 by root 2. Then if we take 1 by root 2 as common, then this is the function can be written as 1 by root 2 into 1 plus j, right? So see, if you observe here, root over omega mu into sigma and e power this function can be written as cos 45 plus j sin 45, right? As we know that cos 45 value is 1 by root 2 and similarly for sin 45 is also 1 by root 2, hence 1 by root 2 into 1 plus j and omega mu into sigma. So in place of omega, we substitute means as we know that angular frequency omega, the formula is given by 2 pi f, right? So gamma is nothing but root over 2 pi f mu sigma into 1 by root 2 and to 1 plus j, right? So upon simplifying that equation, then gamma equal to root over 2 pi f mu sigma into 1 by root 2 into 1 plus j, right? So if you simplify this one, then 2 pi f mu sigma by root 2 means then 2 plus j into 2 pi f mu sigma by 2 root over, okay, separate j, right? So 2 gets cancelled, pi f mu sigma root over plus j into root pi, this 2 gets cancelled, pi f mu sigma is gamma. So here the real term is to be considered as alpha and the imaginary term is to be considered as beta, right? So gamma equal to alpha plus j beta equal to pi f mu sigma root over plus j into root over pi f mu sigma, right? So alpha equal to beta equal to then pi f mu sigma plus root over, right? So for a good conductor, this one alpha, attenuation constant alpha and phase constant beta are real and both are directly proportional to the square root of frequency and the conductivity. See here, if you observe, alpha is directly proportional to the sigma and the frequency and beta is also directly proportional to the this f and sigma. Okay, so for a good conducting medium, attenuation constant alpha and the phase constant beta are same. Okay, so and those two are directly proportional to the square root of frequency and conductivity of that medium, right? So how we have evaluated this attenuation constant alpha and the phase constant beta along with that propagation constant gamma, I think you people are understood, right? Then intrinsic impedance eta we are supposed to consider as next. So in general, intrinsic impedance eta is given by, it is the ratio of electric field strength E to the magnetic field strength H. and it is equal to, in the characteristic equation, root over j omega mu by sigma plus j omega epsilon. Then again as simple, eta equal to j omega mu by sigma plus j omega epsilon. Then if you take here j omega mu by, if you take here as sigma is common, then it becomes 1 plus j omega epsilon by sigma root over, right? So j omega mu by sigma into 1 by 1 plus j omega epsilon by, we substitute sigma by infinite root over, then this becomes j omega mu by sigma, then something like this infinity means total term tends to 0, 1 plus 0, 1, 1 by 1 becomes 1, then this is the equation is to be obtained for eta. And we can separate here this complex function means omega mu by sigma root over into root j, right? So this one, as we know that if you substitute sigma by infinity, also we'll get the same result, or else if you consider the condition as sigma is far greater than that of omega epsilon, then this is the case also. If you simply neglect this total term, then we are going to get eta equal to root over omega mu by sigma into root j, right? So, and similar function, as we know that this omega, if we substitute omega by 2 pi f mu by sigma into root, and this root j can be written as 1 at an angle of 90 at root 90, then 2 pi f mu by sigma into 1 at an angle of 45 is to be obtained. This can be written as 2 pi f mu by sigma into this one e power j45, and here 2 root over 2 pi f mu by sigma into, this can be written as cos 45 plus j sine 45 again. So cos 45 is 1 by root 2 plus j sine 45 is also 1 by root 2. So 2 pi f mu by 2 into sigma root, then 1 plus j s remains. This 2 and this 2 gets cancelled, then pi f mu by sigma into 1 plus j is obtained for the value of intrinsic impedance eta, right? So eta equal to root over pi f mu by sigma into 1 plus j, and here the angle is considered to be as 45 degrees. Why? Because as we know that e power j 45 value is 1 by root 2, and root theta is to be evaluated for 90 degrees. Hence, electric and magnetic fields are to be separated by 45 degrees. Why? Because in general, this eta is to be defined as electric field strength E to the magnetic field strength H. Then eta equal to E by H is to be obtained. Okay. So, eta equal to E by H. Then, for a good conducting medium, the intrinsic impedance eta and means based upon this intrinsic impedance, the electric field strength E and the magnetic field strength H are differed by 45 degrees. Right? So then, next is skin depth or depth of penetration. So in order to learn about this skin depth or depth of penetration of electromagnetic wave, we have to consider uniform plane waves in good conducting medium, or how the uniform plane wave is propagating in good conducting medium, right? So now, in order to know that skin depth or depth of penetration, and it is denoted with small delta, then we have to consider one a simple image, that is the illustration of skin depth means the electromagnetic wave is propagating in z direction, right? So here E naught or Ex be the maximum amplitude of the wave, and how it is to be reduced 0.368 into E naught or Ex. Based upon that, we are going to define the depth of penetration or skin depth of electromagnetic wave. Okay, so in general, the notation for that skin depth or depth of penetration is delta. Okay, then the component of electric field Ex means, in order to analyze this one, first consider the component of electric field Ex is traveling in positive z direction. So initially, in the definition of uniform plane wave, we have considered one simple assumption as if x, y, z three directions are to be considered, then in this, if electric field is traveling in x direction and the magnetic field is in y direction and the wave which is to be propagating is in z direction, right? So based upon this uh, assumption, we have considered two Maxwell's equations. Then from that we have derived an electromagnetic wave equation that is also called as uniform plane wave equation, right? So then the component of the electric field Ex, why? Because initially we have assumed the electric field is in x direction. Okay, so the component of electric field Ex is traveling in positive z direction. That's why the direction is to be considered as z. Then Ex is equal to Em plus into e power minus alpha z. Why? Because that Ex is equal to Em plus into e power minus gamma z, right? So this is the skin depth or depth of penetration is to be analyzed with respect to the which medium? Good conducting medium. So for that, the propagation constant gamma and attenuation constant alpha and the phase constant beta are to be same, right? So alpha equal to beta equal to pi f mu sigma, right? So based upon that, if you are assuming this gamma by alpha or else j beta, so e power minus alpha z, which is equal to em plus into e power minus j beta z. Why? Because for a good conducting medium, attenuation constant alpha and the phase constant beta both are same, right? So that's why ex is equal to em plus into e power minus alpha z or em plus into e power minus j beta z. See here, em plus stands for the wave is to be traveling in forward direction or positive z direction. Suppose if you consider em minus here, so that minus stands for the electromagnetic wave is to be traveling in backward direction or negative direction, right? So plus stands for here positive direction. That's why ex is nothing but em plus e power minus alpha z or em plus into e power minus j beta z, right? So alpha and beta are the attenuation constant and phase constants of the wave, and z is to be propagation direction. And so in order to learn or in order to derive the equation for skin depth or depth of penetration, first at z is equal to 0, amplitude of the component ex is e naught. See, so if you are assuming ex is equal to em plus into e power minus gamma z, or ex is nothing but em plus into e power minus alpha z, right? So at z is equal to 0 means first if you substitute z by 0, then ex is equal to em plus into e power minus 0. So e power 0 value is 1, hence it is equal to em plus or e naught. So that's why its value is to be considered at 0. At z is equal to 0, the maximum of this amplitude is given by e naught or em plus. E naught or em plus. Okay. So at z is equal to amplitude of the component ex is nothing but e naught or em plus. Okay. Then at z is equal to delta, means at one delta distance, means substitute this z by delta or d. Distance is denoted with d. So this can be written as ex is equal to e naught into e power minus alpha into d, right? So d is the distance of that. Now at z is equal to, in the distance z is equal to delta, the amplitude gets reduced by a factor e power minus alpha d. Okay, so Ex is nothing but Em plus into e power minus alpha into d. So if we select that d by, the distance is to be considered, d or delta is to be considered as, if we select delta is equal to 1 by alpha, then the factor becomes, means Ex is equal to Em plus into e power minus alpha into, if we select this d by 1 by alpha, then this gets cancelled, Em plus into e power minus 1, and its value is given by 0.368 into Em plus. Okay, suppose if we convert it into percentages, then it becomes 36.8 percentage of Em plus. Means in one small delta distance case, the electromagnetic wave is to be considered as the distance of, means 36.8% of the Em plus, or the wave is to be penetrate into the medium is 36 or 37% of the Em plus, or the amplitude is to be reduced by 37% of its original amplitude, right? Based upon that, we will define the skin depth or depth of penetration of electromagnetic wave is the skin depth. Delta is measure of the depth to which an electromagnetic wave can penetrate into the medium. Penetration is nothing but insertion. Okay, so the skin depth is a measure of the depth to which an electromagnetic wave can penetrate into the medium is called skin depth or depth of penetration of electromagnetic wave. Okay, so and E or H, electric field strength E or magnetic field strength H, wave travels in a conducting medium. Its amplitude is attenuated by, means reduced by. Attenuation is nothing but reduction of the amplitude, or reduced by the factor e power minus alpha z. The distance delta through which the wave amplitude decreases by a factor e power minus 1, means 37% of its original value, is called skin depth or penetration of depth of the medium, and it is denoted with delta. Okay, so E naught into e power minus delta alpha, which is equal to E naught into e power minus 1, then its value is nothing but 36.8 percentage of E naught. Okay, so in one small delta distance case, the amplitude of the wave is to be reduced by 37% of its original value, right? Or in simple way, how we are going to define the skin depth or depth of penetration of the medium is nothing but the wave, it is the depth of penetration or skin depth can be defined as the penetration of the wave, the depth at which the electromagnetic wave is to be penetrate into the medium is called skin depth or depth of penetration of the medium, right? So based upon that, we will define this delta, small delta, equal to 1 by alpha, which is equal to 1 by beta, which is equal to root over pi f mu sigma, right? So based upon this equation, we can say that delta is nothing but skin depth or depth of penetration of the medium is directly proportional to the, indirectly proportional to the square root of frequency and conductivity of the medium, right? So what we have learnt in this lecture is, firstly, we have seen three characteristics of that, how the electromagnetic wave motion in the different media we have discussed, that is free space medium, sigma equal to 0, then epsilon equal to 0, and mu equal to mu naught. For a free space medium, if you substitute sigma equal to 0, means in general, we know that propagation constant gamma equal to j omega mu into sigma plus j omega epsilon root over. Then in this case, if we substitute sigma by 0, then j omega mu into j omega epsilon is to be obtained. Then from this, j omega, if we take as common, root over mu epsilon is left out, and it is nothing but alpha plus j beta, right? So based upon this, alpha equal to 0 as sigma equal to 0, then beta equal to omega root over mu epsilon, right? So if sigma equal to 0, alpha equal to 0. As we know that alpha is nothing but attenuation constant. If alpha is 0 means there is no loss in the signal. Attenuation is nothing but reduction of the amplitude, or reducing the amplitude of the signal is said to be attenuation, right? So if there is no attenuation means there is no loss in the signal. Hence, this one, for a free space medium, sigma equal to 0, epsilon equal to epsilon naught, then mu equal to mu naught. Similarly, one more characteristic equation for this, eta equal to j omega mu by sigma plus j omega epsilon root over. Again, if you substitute here by sigma by 0, then j omega mu by j omega epsilon, then j omega gets cancelled, mu by epsilon is left out, right? So for this, for a free space medium, root over mu by epsilon is to be obtained, right? Then for a lossless dielectrics, if sigma equal to 0, epsilon equal to epsilon naught into epsilon r, mu equal to mu naught into mu r. As we have discussed in free space, similarly here also for a lossless dielectrics, if sigma equal to 0, alpha equal to 0. If alpha equal to 0, there is no loss in the signal. Hence, the lossless dielectric medium is also called as perfect dielectric medium, right? And based upon that, the intrinsic impedance also we have derived. Then that is the case, intrinsic impedance eta is the ratio of the electric field strength E to the magnetic field strength H. And in that case, lossless dielectric medium or perfect dielectric medium, electric field strength E and magnetic field strength H are differed by 0 degrees phase shift or in phase to the each other. And lossy dielectrics, as the name itself resembles us, that lossy means there must be some loss. Hence, sigma is to be assumed as which is not equal to 0. Then epsilon equal to epsilon naught into epsilon r, mu equal to mu naught into mu r. And in the today's lecture, we have discussed how the electromagnetic wave is to be propagating in good conducting medium. So in order to analyze that one, firstly we have assumed sigma is approximately equal to infinite and epsilon equal to epsilon naught and mu equal to mu naught into mu r. So in order to analyze all such, firstly we are going to have here attenuation constant alpha and the phase constant beta, then propagation constant gamma, then intrinsic impedance eta. So these are the formulas are important to analyze the wave propagation characteristics in the different media. Then loss tangent and loss angle, as depending upon those two, whether the given medium is which medium is given, whether it is dielectric medium or perfect conducting medium. So in order to analyze this one, firstly the condition is sigma is far greater than that of omega epsilon, then sigma is to be assumed as infinite and epsilon and mu naught. Then propagation constant, after that we have analyzed intrinsic impedance eta. So in this case, intrinsic impedance, electric field strength E and the magnetic field strength H are to be differed by exactly 45 degrees, right? So how this root theta is to be applied and all we have learnt in this particular lecture. Then after that we have defined this one, skin depth or depth of penetration. It is the depth or skin depth or depth of penetration is to be defined. The depth at which the electromagnetic wave is penetrating into the medium is called skin depth or depth of penetration, and it is denoted with delta. And then the formula is given by mathematically we can express this delta equal to 1 by alpha equal to 1 by beta, which is equal to root over pi of mu sigma. From this we can say that skin depth or depth of penetration delta is inversely proportional to the square root of frequency and the conductivity of the medium, right? So next one, last one, So how the electromagnetic wave is propagating into the free space medium. So in a free space medium, sigma equal to 0 and epsilon is nothing but epsilon naught, mu is nothing but mu naught we have considered. Means for a free space medium, relative permittivity epsilon r and relative permeability mu r is replaced by 1. Hence, epsilon is nothing but epsilon naught and mu is considered to be as mu naught. Why? Because in general, the formulas for mu is mu naught and mu r and epsilon is epsilon naught into epsilon r. If we replace these two by 1, then mu is to be considered as a mu naught and epsilon is to be considered as epsilon naught. Then, in a free space medium, sigma is to be assumed as 0, then epsilon equal to epsilon naught, then mu equal to mu naught. Then alpha equal to, as we know that propagation constant gamma is alpha plus j beta equal to j omega mu into sigma plus j omega epsilon root over. Then if we substitute sigma by 0, j omega mu into j omega epsilon root over, then j omega into root mu epsilon is to be obtained as propagation constant gamma. Means gamma is equal to alpha plus j beta equal to this equation. So here there is no real term, means alpha is equal to 0 and beta equal to omega root over mu epsilon. Okay. So then alpha equal to 0, beta equal to omega root over mu naught into epsilon naught. Right. So for a free space medium means we just replace mu and epsilon by these two, then beta equal to omega root over mu naught into epsilon naught. Then velocity equal to, as we know that velocity equal to 1 by root over mu into epsilon, then which is nothing but c. So that is 3 into 10 power 8 meters per second. How this value is to be obtained means 1 by root over. As we know that mu naught value is 4 pi into 10 power minus 7 and epsilon naught value is 8.854 into 10 power minus 12 root over. Right? If you calculate its value is approximately equal to 3 into 10 power 8 meters per second. Right? Hence, for a free space medium, velocity of the medium equal to velocity of light, and that is 1 by root over mu naught into epsilon naught, and its value is approximately equal to 3 into 10 power 8 meters per second. Right? And where lambda is said to be wavelength of that medium, and it is to be obtained as 2 pi by beta. Beta is propagation constant. Then next, intrinsic impedance eta. Eta equal to j omega mu by sigma plus j omega epsilon root over. Then for a free space medium, if we substitute the sigma by 0, then j omega mu by j omega epsilon root over. This j omega gets cancelled, root of mu by epsilon is to be obtained. For a free space medium, this mu is replaced by mu naught and epsilon is replaced by epsilon naught. As we know that epsilon naught is 8.854 into 10 power minus 12 farad per meter and mu naught is nothing but 4 pi into 10 power minus 7 Henry per meter. Then if we substitute mu naught and epsilon naught values by these two, then 4 pi into 10 power minus 7 by 8.854 into 10 power minus 12 root over. Okay. Then, which is nothing but here, its value is to be approximately equal to 120 into pi or 377 ohms. Why? Because intrinsic impedance, no? So it is the complex form of the resistance. As we know that resistance is measured in ohms. Similarly, intrinsic impedance eta is also to be measured with the same, that is ohms, right? 120 into pi or 377 ohms. For a competitive exams orientation also, thus the eta naught, intrinsic impedance of the free space medium value as means 120 pi or 377 ohms. Okay. Then, so eta naught equal to root over mu naught by epsilon naught, which is equal to 120 pi, then 377 ohms is called the intrinsic impedance of the free space medium. Right? So, with this, the part 1 of wave characteristics are to be completed. So, what we have discussed, how the electromagnetic wave is to be derived, how the electromagnetic wave equation is to be expressed in phasor form, and from that we have derived Helmholtz equations, that is del square E minus gamma square E equal to 0, and del square H minus gamma square H is equal to 0. These two are called Helmholtz equations. Then from this we have defined attenuation constant alpha, phase constant beta, propagation constant gamma, and intrinsic impedance eta. And the evaluation of attenuation constant alpha, phase constant beta also we have learned. Then after that we have evaluated the intrinsic impedance of the medium as eta. Okay. Then we have analyzed how the electromagnetic wave is to be propagating in different media. We have learned. That is, for a free space medium, how gamma and the eta naught are to be varied. And in the dielectric medium, we have discussed three cases as the lossless dielectric medium and lossy dielectric medium, followed by practical dielectric medium. In three different cases, different conductivity are to be considered. For a lossless, sigma equal to 0. For a lossy and practical dielectric case, sigma is not exactly equal to 0. Based upon that assumption, we have got propagation constant gamma and intrinsic impedance eta are to be evaluated. From the intrinsic impedance, how the electric fields and the magnetic fields are to be differed, and how much phase shift is a difference between two are to be learnt. And in the last topic in that is uniform plane waves or electromagnetic waves are to be propagating in the conducting medium, we have learned. Then from that we have derived one of the mathematical equation for that. Skin depth or depth of penetration of the good conducting medium is delta, and it is nothing but 1 by alpha equal to 1 by beta equal to 1 by root over pi f mu sigma. Then from this we can say that skin depth or depth of penetration of the medium is inversely proportional to the square root of frequency and the conductivity of the medium. Right? So in the characteristics 2, electromagnetic wave characteristics 2 part, we'll continue in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.